In this unit, we're going to talk about the properties of water, which is an amazing molecule. It's the only one that exists on planet Earth in all three states, solid, liquid, and gas. The solid is less dense than the liquid, and so you can see here in this picture, this iceberg is floating on water, and that is really important for the lives of things that live in water. If ice didn't float and sank instead, nothing would be able to live in the water. Adhesion, cohesion, and surface tension are also really important aspects or characteristics of water molecules. Adhesion, the AD part, means that this water molecules will stick to molecules other than water very well. Cohesion means that water molecules stick to each other very well. And surface tension means that it's difficult to break the surface of water. And so you've probably seen this when you might have poured a liquid or plain water into a glass and noticed that the top of the water bulges over the side but doesn't quite fall down. So that's an example of the surface tension. And all of these three characteristics are due to the hydrogen bonds. Water is also a universal solvent, meaning that just about everything dissolves in it. It has a high specific heat, and that means that it takes longer to increase the temperature of 1 unit of water 1 degree than it does for a lot of other molecules. And water also contributes to evaporative cooling. So for instance, when you sweat to cool your body off, the evaporation of those water molecules actually helps to keep you cooler. So this brings us to acids and bases. Acids and bases are related to water because they dissolve in water, and an acid increases the relative hydrogen ion concentration. So this H+ is hydrogen ions. One example of this is hydrogen chloride dissolving into hydrogen and chloride ions. And so hydrochloric acid is another name for hydrogen chloride. Bases dissolve in water and decrease the hydrogen ion concentration in the solution. So ammonia here is an example of a molecule that is a base. So you start out with NH3, which is ammonia, and some hydrogen ions, and NH4+ is what you end up with. And so this plus here shows that the ammonia has taken up a hydrogen ion and become an ammonium ion. So the pH scale shows relative amounts of hydrogen ion concentrations. A smaller number means that more acidic compounds are where you're looking at them on the pH scale, and a larger number means that you're looking at more basic compounds. Something with a pH at 7 is neutral, and so let's look at the pH scale. Compounds or substances that we call buffers can bring the pH of a solution towards neutral, whether it is acidic or basic. And this is really interesting because this shows you that things like battery acid and stomach acid are also very acidic. So very acidic things are at the low end, pH of 1 or 2. Lemon juice has a pH of 2. Tomatoes are at 4.5. Water tends to be around 7, depending on where you live. Eggs are at roughly 8.5. And then strong bases are at the high end of the pH scale, and they include things like bleach. So another interesting aspect of the pH scale is that you can combine a strong acid and a strong base to end up with a neutral solution.